Welcome to Trends in AI, live from the European Conference on Information Retrieval 2023 in Dublin. Beautiful weather outside. With us today, a special guest, Nils Reimers from Cohere, who just gave a keynote in the, a rather good keynote in the industry day about multilingual neural search. So welcome on the show, Nils.
Yeah, thanks. Happy to be here.
So first of all, how was your ECIR? We haven't had such a good in-person information retrieval conferences in a while. How has your experience been?
Yeah, so far really good. So it's my first IR conference. My background is more in NLP and also like on these NLP conferences, ACL, NLP. But yeah, over the recent years, more and more going into information retrieval, as it's a fascinating field. Like really, how can you find relevant information and present it in like the most efficient way to users? That's, yeah, everyone is dealing with like information overload, and you basically just want to have like really that one information that's helpful for you at the moment.
Yeah, and so what's kind of your top experiences at the conference? What did you see and hear?
Yes, so users, sorry, the people, the members are super friendly. It has a really nice size for me. So I personally like a smaller conference a bit more. So EMLP was like several thousand people, yeah, or like NeurIPS was 10,000 people. It's a bit overwhelming for me personally. It's also a bit harder to connect to people because at NeurIPS you see them once and then they're somewhere else, or you know your colleague is there but you don't see them. And here's like really, yeah, you're still able with several hundred people, still able to have like deep, meaningful conversations and really go do a deep dive on many interesting topics.
And so neural search has kind of taken over the field more or less, right? Have you seen any talks that were not mentioning neural search?
Yes, so neural search is an interesting topic, especially with like younger people, more recent people in the field. But challenge is really scaling it up. So in the industry, so there was like one talk from Bloomberg demonstrating their own architecture. They have internally like 100 terabytes of data, 100 billions of files. And this is still a big challenge for neural search.
On old school Solr.
Yeah, it runs on Solr because it's really scalable at that size when you scale to like thousands of machines and hundreds terabytes of data and 100 billions of files. And so what I found here and had like nice, interesting conversations is like, yeah, how to make neural search doable on that scale.
Yeah.
So people in that field who know more about index optimization and like these Solr, optimized Solr to see, they are really surprised how inefficient neural search and semantic search still is.
It kind of blows up your compute, right?
It blows up your compute already on what they consider small indices, like, I don't know, like 100 million, like in English Wikipedia, that's 6 million files. It's still really expensive to run neural search on like English Wikipedia. And they say, okay, yeah, it's just 6 million files, but now you have like 60 billion or 600 billion files.
Yeah. I don't think there's that many people running Colbert in production yet.
No, not yet. And yeah, that's also the difference you see in academia. So in academia, you have this one static collection, which you know beforehand, and then you run your benchmark on it. But yeah, if you bring it to production, you have the challenge. Data comes in, data needs to be modified, data needs to be deleted. There's a lot of potential also for research, how to make this efficient and workable at scale.
Yeah, and so ECIR is a European conference, and I think one of the sort of key differences in Europe is our languages, right? We have so many of them. And your talk was about multilingual search. So can you sketch a little bit kind of the key problems when you have going from this classical lexical keyword search and what kind of challenges you have with multilinguality and what kind of solutions neural search provides?
Yeah, sure. So I'm native speaker German, and yeah, in my emails, like 50% is German, 50% is English, and also at previous work at previous companies where like 50% of employees were German, communicating often in German and like writing information in German, and the other half were like international working groups, like working in English. There was extremely difficult to find information, like because you never knew, okay, is the relevant information in English, is it in German? And yeah, if you span it up to like more national companies, what you have in Europe, where you have a product for like all these different European countries, you have to support a solution that works for, I don't know, like the 20 languages, 30 languages we have in Europe. I don't know, like a lot of languages we have in Europe. So it really needs to support this. And yeah, lexical search has a problem because it's if you put in data in Spanish and you search in Greek, it's not able to do the match. So it's different alphabet. And here semantic search is a nice approach because it abstracts the way on words. So it's not anchored in words and say, okay, this is the word cat and this is the word bike, but it tries to find the meaning of the words. Mm-hmm. And the meaning of words can be language independent, like a bike in Spanish is the same as a bike in German, as a bike in Greek. So you can abstract it from like away from the surface, from like which word do we assign to an object? And then you're able to search for like, okay, how long do cats live? This can you abstract away from the language you use and then find the relevant information independent of the language.
Yeah, so kind of the high dimensional vector space as the Rosetta Stone between all of these languages.
Yeah, right.
Is that the sort of the vision that you have, that kind of regardless of the language, you would just do nearest neighbor search in a high dimensional vector space?
Correct. So you abstract it away from the language because often the language is not really that critical in search. And you just abstract it away to the meaning. And the meaning, I would say, is like language independent.
Yeah. And so most people know you as the creator of the sentence-BERT library. Now you're at Cohere. I guess you have pretty decent computational resources at your command. So can you tell us a little bit the evolution of multilinguality going from sentence-BERT to what you're doing now?
Yes, so multilingual sentence embedding, I've been working quite long for this. So first models came out in 2020, feels ages ago. Big problem there, they're using a translation approach, and sadly it just works on a sentence level. So on a sentence level, it works quite well, the models that are available so far. But really in a search level, you have the challenge that you have a short question, like how long do cats live, for example, mm-hmm. And then you have like longer paragraphs that might or might not contain the answer. And this produces like new challenges for these models because they have to align it like in many languages in the vector space. So it's a lot harder to train these. And here at Cohere, when I joined, was first of project I've been working on with my team is getting data, also getting representative data from a lot of countries, from different languages, to really be able to get the interest from different countries, because people in Korea, they're interested in other topics than people from the US, and they are interested in other topics than people from Brazil. So really get like a good representation of the world of interest, what are topics, questions they find interesting, and then bring everything in the vector model. And it turned out it works really impressive
So the core idea is kind of simple and still based on these contrastive self-supervised learning.
Yeah.
But it's you guys have been able to collect data at a much higher scale and also train larger models, I presume.
Correct. So we collected roughly 1 billion training pairs in English, 500 million training pairs in non-English. Big challenge is here data cleaning. So if you just do it for one language, you can see, okay, what are like the error cases?
Especially if it's a language that you speak well.
Yeah, if it's a language you speak well, you can look at it and see, okay, this data point doesn't make sense, you remove it, and then you find patterns. But if you do it for, let's say, Chinese, you need to see, okay, what are the error cases you extract from Chinese as we extracted from the web? These are different error cases based on the country and the language. So language is often highly correlated with the country.
Yeah.
And then also, how do we see it?
And do you need like native speakers to curate this data, or can you do it purely like in a black box unsupervised way?
So luckily my team speaks quite many languages.
Quite a diverse team. Yeah.
diverse team. Amr has been working on this, who's from Egypt, speaking Arabic. Adrian has a French background, and then often we did some tests and like, does it work in German? Does it work in French? Does it work in Arabic?
Right.
As a first test. If we are not able to check it, also use Google Translate. And we have also in my team people from with Chinese background, native Chinese speakers. So this is like extremely helpful. And then, yeah, but it's not really scalable on like a billion scale to look at every training pair individually. So we needed to find like statistical properties. So for example, one big issue have been in Europe, like these cookie consent banners that pop up and ask you, okay, do you want to agree to like our data privacy before you can see the page? And then we had to filter this out and say, okay, this is like not really something we want to have in our model. But here you see, okay, there's like some really high frequent terms, really high frequent content that pops up. And then you filter out these because these are like often repetitive things, which you see like a million times. And then it's really unlikely if you have a question that a million times it's the same answer. Instead, it's like, yeah, the cookie consent banner or like some paywall.
Yeah, and so you've been at Cohere now how long?
8 months.
8
roughly.
months. So
yeah.
Congratulations, because you guys have already released these models, right, as a product.
Yeah.
That's a pretty incredible accomplishment. Yeah, how do you see kind of more the product landscape? So obviously, with GPT coming out, is also like in the generative model space, very fluent in many languages, and GPT-4, we don't know yet what it can exactly do, but it seems to be quite good. So how do you see kind of this multilingual embeddings model in this sort of competitive space, and in general for applications and customers? What are the kind of things that you're hearing?
Right. So yeah, at Cohere we're focusing on two things. I'm there to train the text understanding models. My colleague Phil is training the generative models. In terms of business strategy, our business strategy is a bit different than OpenAI and Azure. So OpenAI tries to get the data to you and tries to move you to Azure, to use Azure, which a lot of people also in Europe are not really happy with. So in Europe, we have GDPR. If you hand over like any customer data to OpenAI, you're breaking GDPR. If there's a request coming in for your company to please delete my data, you have to go to OpenAI, delete the data from OpenAI, which is not possible. So what we say, it makes a lot more sense to bring the model to the data.
Yeah, so you guys are thinking about like local data center deployment, even on-premise deployment.
Correct, on-premise deployment. We have a solution for AWS where the models can run in your own cloud. So you spin it up, and then you deploy these models in your cloud environment, ensures totally data privacy. So no data is like going to us. So you're compliant with like every GDPR or whatever policy you have. And it's also really good in terms of latency. So in search, we really care about latency. It does not make so much sense as a European to send your query to the US to OpenAI and get the embedding back to then search and have like half a second search latency. Makes more sense to take the model there where the database is.
And do you need like a supercomputer in your for your on-prem deployment, or do you need to hire half the data center from Azure?
So for text understanding, big focus for me is efficiency to make it like really distill the model to an extremely small size, which can run at a really low latency. So
even with these like, how many languages do you support?
100 languages. 100
languages in a small model and at state-of-the-art performance.
Correct. So it runs on a single A10 GPU or on a T4 GPU, so with really low latency.
Wow.
Generative models, there we still see
there the scaling has different properties.
Their scaling has different properties. You need more parameters, but roughly on AWS we can deploy it on like a 8x A100s machines. We're working with AWS to also offer, sadly they're just offering like a single. So if you want to have an A100 GPU, you have to take 8 from them. There's like no option just to take like 2 or 4. But yeah, we hope AWS offers like other options, but other cloud providers like Google Cloud, they offer to use smaller units. And then you can also run it like on smaller units.
And so this is, of course, evolving really well. And one of the things that I'm very much fascinated by is actually the combination of semantic neural search in a multilingual setting, and then having these generative models make sense of the data. And, I think that the sort of the productivity benefits are especially in that combination and in making summaries, digests, extraction on the fly, all these kind of things.
Agreed.
So one of the problems that you see with these generative models is that they hallucinate. Can you explain a little bit how you guys look at this problem and this combination of retrieve and generate?
My colleagues Sebastian and Patrick Lewis, they are working on this to combine retrieve and generate, and also to tackle the issue of hallucination. We see a lot of possibilities for the generate models if it works on your data. So we as knowledge workers spend a lot of time. I don't know, my boss pings me and say I'm like a sales agent, pings me, hey, can you give me a summary about the sales calls you had this week? And then I have to write the long email and say, okay, with customer A, this is the progress, with customer B, this is the progress. It would be really helpful for me if it's connected to my CRM data, to the transcript of my sales calls, and I can just ping in and say, hey, write a summary of the customers I had. Or even better, my boss could do it, so he does not needs to bother me, and just goes and say, okay.
Hallucinations could be a real problem in that scenario.
Yeah,
is there a way to kind of to guarantee that there's no hallucinations, or is this something that as we move to this sort of new paradigm, we'll kind of have to educate ourselves about how to work with it?
Hallucination, you totally don't want to have a model which is like completely free of hallucination.
Otherwise it's very boring, right?
It's very boring. So one example is, for example, we see a lot of interest search on documentation for programming APIs, frameworks. So for example, Stripe API. I ask a question, how can I use the Stripe API to check a credit card in JavaScript? But there's sadly no code example how to do it in JavaScript. There's just a code example in Python. Right. What would be amazing if the generative model can see it, so it finds the example in Python, and then the generative model produces the working JavaScript version for it. But this is hallucination. It's not like it doesn't exist.
Yeah, it's generative, right?
It's generative. It's producing something new. If it works, it's helpful because now I have the solution that works in JavaScript. If it doesn't work and makes something strange, I'm unhappy, unsatisfied as a user. So the challenge is
generative, but grounded in facts.
Yeah, generative, but helpful and truthful.
Yeah.
So and that's a big challenge. We want that the generative model produces something new, but it should still be correct.
Yeah. So I guess it's a very new space, right? This has applications in companies. How certain are you that let's say by in 6 to 12 months we'll be in a good place there where people trust this technology?
Trust is another thing. So I think in terms of technology advances, we're seeing really good progress. So really Patrick and Sebastian, my colleagues, are making tremendous progress on this, annotating like a lot of data. So these models need to see more and more data. So that's a big paradigm shift we see right now in the field, that data annotation and quality of data increases in terms of importance. In terms of user trust, I mean, that's a bit more challenging, more sensitive. I think it really depends on first user experiences. If the first examples for a user doesn't work, they drop off. They say, okay, I'm not using the system, and they can be really sensitive to a single example. Maybe it works on 99 examples. If they hit the one example where it doesn't work,
I think it's also kind of a question of generations, or I think high school kids these days already like completely fluent with ChatGPT in 2 months. Older users maybe still using Boolean search, etc. So I think not everybody will maybe evolve at the same speed, right?
Yeah, also a question, what are at stakes? So for high school students,
what's the risk?
It's just a writing essay.
Getting caught by the teacher.
Maybe getting caught, but if you make the mistake in your writing exam, it's probably, you get -1 point or so if the teacher even noticed. If you use it and put it into like a contract, which is like $1 billion deal for a merger between, I don't know, 2 large banks, and it hallucinates some content there, it can be like really, really bad.
Yeah.
Or in programming, you use these generative models to produce code, and then you push the code to your production system, and it deletes, I don't know, all the user data or
yeah. So you think
user
we should kind of go more, not so much by, user sort of level of comfort, but really by the risk, put different risk tiers in the application, and then make policies around that.
So if I send my boss a summary of how the client deal is progressing, and the model makes a mistake and hallucinates a thing or forgets a thing to mention, probably it's not that bad. It's the question if my boss will notice it anyway, because often I mean, in many settings we ask for these executive summaries, but then we just look at the title.
Well, your boss is gonna make a multilingual neural embedding of it and just add it to their file, right?
Yeah. So maybe here the impact, but yeah, the higher the stakes, like especially in a medical setting, if you ask these generative models, how can I treat my disease, the stakes are extremely high, because there can be, you can risk lives, and it can be like a matter of deaths or surviving. And this is like a lot more critical than, okay, I gave a wrong update, what my team has been working on. Yeah, AI safety is this big topic in general. You don't want the model to produce harmful content, toxic content. You need to identify which areas should it restrain to give an answer, because we're too uncertain, like for example, health related things. And it's really hard to balance there, because sometimes if customers use it, for example, to do toxicity detection, they don't want to have like this toxicity detection filter in it. They say, okay, yeah, I know I want to use the system to filter out like toxic content, so the model should still understand the toxic content. Or they want to do like a study and show like risk on like, okay, what happens if you use the model for health related questions, be able to study on this. Is it useful?
Is this kind of reinforcement learning from human feedback? Is that the general direction for all these kind of safeguards?
Yeah, so right now it's a lot. Like currently it appears that reinforcement learning from human feedback, where you ask for like human preferences. So you present 2 outputs, and then what's the human preference on these two.
So very powerful.
It's very powerful. You still need to educate annotators. So that's a big thing, that we don't fall into fallacy, like we say, okay, what is better, A or B? So for example, annotators, they fall for the fallacy of like fluency. So for example, you ask some medical related question, and then the one answer is the what you should do, but it's like has some grammatical errors, and the other is like, okay, that's
sounds good, but
sounds good, but it's wrong, but it's like really fluently written. And then we people also fall for like what is fluently written. And this goes back into the model to see, okay, it's better to produce like the wrong answer, but like in a really fluent way, than to produce the correct answer, which is not fluent, has grammatical errors also. So there's a big challenge to educate annotators and working with people training these systems to really ensure and know what people want, like what's critical for specific tasks.
I think you guys are producing amazing products, and congratulations again on your fantastic keynote, and on launching within 8 months at a new employer a very cool product, the multilingual Cohere embeddings. I think it's really important that we have competition in this space, and it's going very fast, and we wish you a good race. And let's have a pint of Guinness to close off this wonderful European Conference on Information Retrieval.
Thanks so much for having me here.
Thanks, Nils.
Thanks.